Okay, folks, now when we left off, we had done the corresponding sides AC to PR. Okay? Now, Allison, you're going to take the next side for us. What goes with BC? What in the other triangle goes with BC?
BC over QR.
Over QR, okay?
And it would be, the next angle would be 30,
Well,
not angle, sorry.
Length.
Length.
Uh-huh.
Would be 35
Yes, ma'am.
over 28.
Over 28. Beautiful. Perfect. Okay? Who wants to take the next pair for him? I've already talked to Gray. Bennett?
The next angle would be,
Not angle.
well, the next line, I can't see.
Next sides? Oh, here, let me do this, Bennett. I'm sorry. That'll make it easier.
It
And
would
you-
be
AB over what?
PQ.
Over PQ. Now, do you see all the sides from this triangle I'm putting on top? And all the sides from this triangle I'm putting on the bottom?
Because that was bigger.
No, there's no reason. I could put these on the top, but I'd have to put all of them on the top, right? I just have to do the same for each one.
And is that why you started with those and put those on top?
If it comes from this triangle, we're going to put them on top. If it comes from this triangle, we're going to put them on the bottom.
Like on the angles, you started with those, so does that?
I was just reading left to right.
Oh, okay.
I was just reading left to right. Bennett, what are the numbers that go with AB and PQ?
20,
20 and
16.
16. Now, how do I know if these things are proportional? For these two figures to be similar, their sides, their corresponding sides have to be proportional. How can I tell if they are proportional? Any ideas? Isabel? Well, let's write them in simplest form. Isabel, what goes into 40 and 32? 8. 8 goes into 40? And 8 goes into 32? Beautiful. Nice. Lou, what goes into 35 and 28?
7,
How many times does it go into 35?
5,
5. And how many times does it go into 28?
4.
Oh, nice. So far, so good. But the next one has to reduce to 5/4 also, or it won't work. Catherine, what goes into 20 and 16? How many times does it go into 20? 4 goes into 25 times, and 4 goes into 16? Awesome. All the angles are equal, and all of the sides are proportional. Okay? Those two figures are similar. Now, we can use similar shapes to do something called indirect measurement. It's so nice. If I want to find out how tall a tree is, I don't have to climb to the top of the tree and throw a tape measure off and have someone grab it at the bottom to tell me how tall it is. Let me show you how this works. Here we go. Similar triangles can be used in real life to indirectly measure objects. Nice. For example, in the drawing at the right, I put it underneath, the ratio of the two heights is equal to the ratio of the two shadow lengths. Okay, let's look at this. Here's a tree, and here's a person. Right? Can I can I write a proportion that represents this? How could I write it? Great?
You would write 5 over 6.
Okay, the person's 5 feet tall and the shadow is 6 feet long. Okay,
You can do 15 on the bottom.
15 on the bottom because we put shadows on the bottom and we put height.
And then I guess G on the top.
Okay, we'll put G on the top for gray. All right, we'll cross multiply. 5 times 15 gives me 75, and then I divide by the number I didn't use. 6 into 75. Anyone know what that is? You've got a calculator, but what is it?
1 and the 7 is 1. 6, 1.
What is that? 12.5. The tree is 12.5 feet. We didn't have to climb up to the top and throw a tape measure over the side to find out how tall the tree is. It would be awesome though, wouldn't it? All right, now let's go down here and I'm going to have to use another video. Well, you know what? I'm not going to start this example on this video. I'm just going to start it on the next video. All right? Good job.